In this video, we're going to look at a few different data sets that give x, y coordinate or coordinate pairs for different functions. And specifically, we're going to look at a process called finite differences where we're analyzing the change in y values or the change in the outputs and how that informs us about what function we have in front of us. All right, so we're going to start off with the function that's hopefully familiar and relatively straightforward to us. So let's go ahead and get into the process. So finite differences, the process of finite differences, what we're going to do is we're going to, first of all, look at the x values. And in order for this process to work or to be able to use this process, what we need are the x values to increase in what we call an arithmetic sequence. So here we go, +2 and +2 and +2 and +2. And so what we're confirming is that we have these x values that increase at a constant rate, or in other words, they increase, they're given in an arithmetic sequence. So this one, we're just going up 2 every single time. So that allows us to use this process of finite differences. All right, so the process of finite differences specifically, what we're going to do is we're going to look at the y values. So I'm going to ask, what do I have to do to this number to get to my next output value or my next y value? And what I'm doing here is I'm just adding 4. And here I'm adding 4. And again, adding 4. And again, adding 4. So this row of differences, we call these the first differences. And what happens with this process is the amount of differences or the row of differences, if they come up constant, that informs us about the degree of the function. Meaning, because I have first differences, that means that the degree of my function is equal to 1. And specifically, what that means is it's a linear function. So I just have, on my function, I've got an x to the first, which means it's linear in nature. And hopefully you can see that from that constant increase, and you're familiar with that constant rate of change or constant increase. That's our slope up here. So the specific for a linear function, it's going to tell us about what our slope is. So let's check out another example here. So we have another data table that gives us different ordered pairs that our function is going to pass through. And what we're going to try to do is we're going to use finite differences in order to determine the degree of the function or what class or family of functions this particular data set fits with. So first things first, always checking the x values to make sure they're arithmetic in nature, meaning I'm going up the same amount or down the same amount in my x values. Those are all +2, just like our first example, so we're good to go. We're good to use this process of finite differences to analyze the degree of the function. So all I'm going to do is I'm going to look at this number right here. I start with a +16, and it looks like I go down to 0, so that would be a -16 change in y. From 0 to 0, that's nice and easy. We don't change, so that's just a 0. From here to here, 0 to 16, I have to add 16 to the 0 to get my next term, and then to get from 16 to 48, I'm going to add 32. Okay, so what we see is when we analyze the change in these output values or these y values, my first differences are not constant. Okay, my first differences are not constant. And what that means is this is not a linear function. Okay, so we didn't figure out what type specifically it is, what kind of function it is, or what the degree of the function is, but we did figure out that it's not linear. So we did get a little bit of information. So what we're going to do is we're going to take it one step forward and we're going to find these second differences. So I'm going to look at my row of first differences, and in that row of first differences, I'm going to analyze the change from one value to the next. So I'm going to say, hey, if I have to go from -16 to 0, what do I have to do? I have to add 16. I have to go up 16. From 0 to 16, also have to go up 16. And from 16 to 32, up 16. So again, now, just like the first one, we found a row of constants, but this time that row of constants is in my second differences. And because it's in my second differences, the constant row, that tells me that the degree of the function is 2. In other words, that tells me that this is a quadratic function, okay, or a squared function, an x squared function. So again, just using finite differences, trying to find a row of constants, and when we do, it informs us about the degree of the function. So let's take a look at one more, go through this process. So we've got this function here. Again, looking at the x values, they're going to increase by 2 every time. So we have that arithmetic nature in the x values. So what we're going to do is we're going to analyze the differences between the y values, or my outputs, in order to try to identify the degree of the function. So I'm going to look at negative 50, and to go from negative 50 up to 2, I have to add 52. From 2 to 6, I have to add 4. From 6 to 58, I have to add 52. And from 58 up to 254, I believe that's 196. All right, so again, going through the same process and just thinking kind of in the back of our heads, those are our first differences. Our first differences are not constant, therefore it is not linear. So let's go ahead and move forward. Let's find our second differences. From here to here, I'm going to go down 48. Here I'm going to go up 48, and this is an important distinction here. These are not constant. We don't consider these a constant row. I'm sorry, a constant increase or decrease, because they have opposite signs. So what we're looking for is the same sign. Notice these are all up here. When you look at this row right here, we've got plus 16 and plus 16 and plus 16. We do need to have the same sign on every increase or decrease as well. And then the last one, it looks like this is going to give us 144. And I'm adding 144. Okay, so again, second row of differences doesn't help us out here. We don't have a row of constants, but what it does tell us is this is not a quadratic function. So let's go one row further. We're going to go to the third differences now. All right, in order to go from negative 48 up to positive 48, I need to add 96. And then to go from my positive 48 up to 144, I again need to add 96. There's my row of constants right there. I've got the same increase in each one. These are third differences. And just like the previous two, this is going to tell me what the degree of my function is. So for this particular case, we've got a degree that's equal to 3. And specifically, that means that we have a cubic function.